Today, we're joined by SJSU faculty Jack Warecki, who's going to discuss the benefits of our online BS and interdisciplinary engineering program. Thanks for chatting with me today, Jack.
Brian, I appreciate the invite, to be honest with you. Excited to be here.
Yeah, I'm excited to chat with you and learn a little bit more about one of our newest programs. So before we get into today's topic, just like we do in every episode, I was wondering if you can help our viewers learn a little bit more about you and your background and how you got to where you are today. And if you can share maybe some of the significant moments or inflection points that led you to becoming an SJSU faculty member and the program director of our interdisciplinary engineering program.
Wow. Okay. So that's a lot to cover right there, or unpack, if you will. So from my perspective, again, I think I'm living proof, if you will. So hopefully listening to me talk about interdisciplinary engineering will give you, provide some credibility. I started out as a math major. In fact, that's when my graduate work was in mathematics. There was no interdisciplinary engineering at the time. Again, this is a while back, obviously. But anyway, the point was that it also gave me a lot of opportunity to work with a lot of different fields because of a math background. One of my first jobs was launching satellites from the space shuttle. I had to write programs, if you will, to actually help the telemetry associated with the launches and so forth. But I had to work with other people that had other skills, engineering skills, software engineers, again, computer scientists at the time, computer engineers at the time. And again, so I had to learn something about, again, how did the mechanical system work for launching a space shuttle? What are sensors? What are actuators? What are things like that? How do I program them? So immediately, my first job was working with other engineers, if you will, even though I was a math major at the time. And so again, that was led to one thing to another and so forth. And then one of the key things I think and talked about an inflection point was in my career was that, again, with my math background, I had heard that there was a problem with people designing computer chips. And the problem was that, again, for many IC designers and integrated circuit designers, they would actually do what's called a logic design, and they also would have a physical design. The logic design that they used was to help create or to make sure that the ones and zeros that come into the chip, and again, the expectation of ones and zeros that come out of the chip were correct. Well, the logic design, they simulated on a computer. The physical design, generally, it was a different person that actually would lay out how do layers, if you will, a material to make, if you will, a transistor. Again, they would do that manually on it was a layout station. And so the problem was that you've got something that's a physical design that's going to go to manufacturing, and you've got a logic design to verify that the design works as it's supposed to. The problem was that these are two different graphs. It's like, think about all the different things that are connected to each other. And we're talking about, today it's billions of transistors, billions of different connections and so forth. But at the time, if you will, there was nothing to verify that. People had to, again, how are we going to do this? And so I was called upon because of my math background. Can I come up with some algorithm, i.e. code it, so that, again, an designer, an integrated circuit designer could verify, hey, the thing that we're actually manufacturing is the thing that I actually designed logically. And I discovered very quickly my math background fell short. And what it turns out that was that when I developed something, again, by the way, those of you interested in the math side of it, adjacency matrices. Turns out that it helps establish connections in a graph. Turns out that when I actually coded all that, it took weekends, again, on a computing processing capability back then, to come up with a very small design to verify that the physical and logic design were the same. Well, when I discovered this is not going to work because, again, chips are getting larger, the amount of transistors on a the real estate of a chip is just booming. And so that's not going to work. So it turns out that when I went to talk to an electrical engineer, an ASIC designer, application-specific integrated circuit designer, I asked them, how do you verify that the physical and logical design work? What do you do? Okay. Again, before, I'm being asked to come up with a program. And they told me, well, we start out with the IO. We start looking at the input pins, and we trace the input pins all the way to the connections and so forth. So it's a heuristic approach. And I discovered I don't need to do the general math approach, if you will, and follow, if you will, what the double E does for verifying your design. Turns out that was the best way to do it. And then came out a layout verification system, which became very popular for us, especially for the company I was working for, because it gave us a competitive advantage. Anyway, but it was my opportunity to work with other disciplines. And again, like I said, launching satellites from the space shuttle was my first job. But then I ended up, again, with my career based on, again, all the different disciplines I worked with and so forth, including non-engineering people. I ended up being a senior vice president for one of the top technology companies in the world, because again, back to engineering management. And so even though my math background, gave me some opportunities, and immediately I became what was called a VLSI design automation engineer. So again, there's a lot of value associated with not just, again, don't get me wrong, being in a specific major, we still need that. We still need chemical engineers, electrical engineers, and mechanical engineers. But again, with emerging technologies and the way technologies are being developed, if you will, especially when they're integrated, again, requires some type of interdisciplinary engineering, someone that could talk to a software engineer, someone that could talk to an electrical engineer or a mechanical engineer. Anyway, that's what my background was, and that's how it got me here. And in parallel, by the way, I love teaching. So I've been teaching ever since I graduated as well. And again, most of the time during my professional career, if you will, on the engineering side, I did teach, for example, a lot of classes. And I'm currently teaching Engineering 10, Introduction to Engineering at San Jose State University. But again, if you look at the position I'm in right now, I'm the interim department head for interdisciplinary engineering. Again, to me, it speaks proof of what I learned and my background got me to where I am today. So again, interdisciplinary engineering, from my perspective, major opportunity for many of you that are considering it.
Yeah, that was a really awesome background. Thanks so much for sharing that with me. And I think your story and those examples that you shared really did highlight just the ever increasing importance of having that interdisciplinary background, that interdisciplinary knowledge, and being able to draw from different disciplines, different theories, different areas of research, different skill sets, especially when you're working as part of a team, as part of an organization, as part of a system. Really, really important. Actually, I didn't share this with you when we talked during our pre-show, but I studied math and econ as well in undergrad, and I ended up going into more of the social sciences route. So a lot of different paths you can go down if you study math in undergrad.
No wonder I liked you, Brian.
Yeah. So I know for this program, you talked about how there's a few primary focus areas. So I was wondering if you can share what those are and some of the examples of the courses that students would take when they're enrolled in this program.
I'll be happy to. Thank you, Brian. So again, what I think you're going to learn in this 2-year program, and this is wonderful. And I know many of you are out there, maybe you've got a ton of, lower division requirements met, but you never finished your degree, and, you'd love to get an engineering degree. By the way, I deal with I do advising as well for the college, and a lot of students that come to me, that are, they're out there already in the workforce, for example, and maybe they're taking a class or two, and maybe even thinking about full-time load. They're saying, you know what, I just want to get an engineering degree. I don't need to have chemical, electrical, mechanical, whatever. I just need to have an engineering degree. The job I'm doing at my company right now, they're not worried about me being a specific major or having a degree in a specific major. They're saying, hey, get that engineering degree, interdisciplinary engineering degree. That's fine. And so I get a lot of those questions like that. So here's what you're going to learn in a 2-year program. So for those of you that might be like, wow, I've got so many of the requirements I believe in the lower division side met. If I apply, this is a great 2-year program that I can actually get my engineering degree. Again, you get stamped interdisciplinary engineering, which is really cool. Anyway, what you're going to learn. So first of all, a couple things. You're going to learn to identify, build formulas and so forth to solve complex engineering problems. Again, by applying engineering, math, and science, just like all the other specific majors do as well. You're also going to learn about developing and conducting appropriate experiments, how to collect, analyze, interpret the data, and come to an engineering conclusion, arrive at an engineering conclusion. Also, it's really important, applying your engineering design skills, again, that produce solutions that not only affect maybe your company or the engineering aspect of your design or of a product or system, but also meeting the needs of society and the environment. Again, today, engineers don't just work necessarily with other engineers. They work with non-engineers, including the community leaders, for example. Again, especially when it comes to sustainability issues in terms of the environment, for example. Also, one of the things you're going to learn, how to be an effective team member. Engineers in the real world, and again, in profession, those of you who might already be doing this, know that you work in teams. So here's another area, again, that we cover as part of the program, which you can give you an opportunity to provide some leadership, provide a collaborative, supportive environment for the team, if you will, help establish what the goals are, the objectives are, how you're going to get there, and planning and so forth. Again, those are critical skills that you want to have as an engineer as well, because again, engineers work as teams in the real world. And again, these 3 major areas, for example, one of them is engineering management and quality control. So you're going to learn about system efficiency, cost reduction, reliability, performance. Again, all for the sake of improving quality and productivity. And again, some of the courses that you're going to be dealing with associated with engineering management and quality control is statistical and probability, process control, operation planning, engineering management, engineering economic systems. So there's a number of things associated with that umbrella. Another key area, and this is very important, and again, as I mentioned earlier, applied computing. Having that knowledge associated with, again, just basic programming skills, the data technology that's out there, structures, how do you actually store information, big data, you may have heard that expression, and data mining. And then also, of course, algorithms. And what that provides for you is, number one, a highly marketable skill. Again, today's world, you need to have that programming aspect associated with it, especially from an engineering perspective. And a third area that we cover, and this might surprise some of you, is something called innovation in law. So today, companies realize that their intellectual property, the things that they develop, the things that they innovate with, okay, is a major asset to them. And they need to protect that major asset. And so one of the areas that we're offering as part of the program called Innovation in Law is teaching you some of the basic concepts of intellectual property and patent applications. You might be surprised, but there are a lot of legal firms, for example, that get a patent application. They can't read the engineering schematics. They don't know how to interpret, again, whether this is something that can be patented or not. Trademark, same thing. And so you get to learn about, again, what is intellectual property, again, introduction to patents, and also really cool classes called Puzzles in Innovation in Law. What is innovation? Why do we need to have laws associated with that? Not only does this help a company or help a legal firm, for example, but again, it also gives you an opportunity to understand, and maybe you have a great idea that you like to consider as possibly patented. But again, having that understanding could add a lot of value associated with either working for a company or your own company, your own ideas as well. Another key area that, again, it's almost an area in itself, and that is mechatronics. So mechatronics is a mechanical engineering course, but it's really cool because, again, what you're going to learn about is sensors, actuators, microprocessors, how microprocessors interface with electromechanical systems. And it's, again, really kind of a combination of mechanical engineering, electrical engineering, computer/software engineering. But it's a great opportunity to see, again, that interdisciplinary aspect work for you. So, again, real live course associated with specifically, again, working with those different disciplinary majors, fields, if you will. And by the way, the engineering management and quality control area that I just mentioned, for example, that it can be applied to other industries. It doesn't have to be applied to an engineering environment, for example. You can apply this into other fields, other industries like retail, healthcare, transportation, manufacturing. Again, a lot of the material that we present as part of the 2-year program in IDE gives you, I think, from my perspective, a great opportunity space. And one thing I generally encourage students, for example, is to actually go into the leading recruiting firms, whether it's LinkedIn, ZipRecruiter, Glassdoor, Indeed. Type in interdisciplinary engineering, see the kind of job opportunities that come up. And you might be surprised because some of them might say electrical engineer required, okay? And it might say or equivalent. Generally, that's HR speak for saying, hey, if you have some engineering skills, we'll consider, again, your application. So take that into account as well. But please take a look at those recruiting firms, see the kind of job opportunities come up, see the space, if you will, that might be of interest to you in addition to, again, having just interdisciplinary engineering degree, how it can help you. All right. I'm
Awesome.
ready for Q&A.
Thanks so much, Jack, for providing all that background and detail about the program. You answered all my questions before I could even ask them. I think that was really helpful, though, to just provide some more detail around what some of the different learning opportunities and outcomes are for students. So you talked about things like problem solving, talked about things like running experiments, working in teams, and then how they will actually do that through some of those primary focus areas of the program, through the engineering management, through the applied computing, through innovation and law, and then really thinking about how those things will be transferable to different career outcomes that people are looking into, and just the overall value of not just what they'll learn within the program, but how they can apply it once they finish up the program, get their degree, and move on to the next step in their careers. So I definitely appreciate you providing all that background. I think those are all the questions that I wanted to touch upon for today, unless there's anything else that you wanted to highlight.
No, I think for those of you that are entertaining possibly getting a career in engineering, and like I said, if you completed a lot of lower division requirements, take a hard look at IDE, interdisciplinary engineering. Again, like I think the opportunity space, especially again, if you're not tied or coupled into a specific type of major, I think interdisciplinary engineering you might discover is a real opportunity space for you.
Yeah, I mean, it sounds really cool to me as an outsider. Sounds like there's a lot of versatility to it and a lot of different possibilities that people could to utilize it for as they're thinking about what they might want to do professionally. And again, just like I shared with you right before we came on the air, what I'm doing professionally now didn't even exist when I was in school. So it sounds like it's something that people could study now and be able to use for years and decades to come.
Exactly. And again, applying it to different fields as well, like the engineering management side of things. Again, I developed a lot of my skills on management side of things. Again, I did it, on the job training, if you will. But again, that fact that I could work with others and understanding their requirements, their problems, their issues, again, from an engineering perspective, really helped me, if you will, promote my career.
Yeah, definitely.
Yeah.
Well, thanks so much, Jack, for sharing your insights and about the value of SJSU Online and the Interdisciplinary Engineering program with us. Thank you to our viewers for watching. As always, make sure you please like this video, comment with any questions and feedback, subscribe for more content, and we'll catch you in the next episode. Thanks, everyone.
Thank you.